So, good afternoon and a warm welcome to our webinar. This webinar is all about Prover Station, a web-based next-generation signaling design automation platform. This webinar is delivered by Prover. My name is Lars Dahlberg, acting as the moderator, going to guide you through this webinar. I've been guiding a lot of Prover webinars, and Prover's been doing a lot of interesting webinars. But this is the first time that we're doing like a proper product launch. In this case, Prover Station. Prover Station was actually launched at Innotrans a couple of weeks ago, but now we're doing this in the format of a webinar so that more people can attend. And it's so interesting to see, exciting to see that so many has decided to join us today. So we're really looking forward to be able to deliver this webinar for you, focusing on Prover Station. This webinar is going to continue for 60 minutes, and we are going to have a Q&A in the end, approximately 15 minutes long. So with that, I think we'll move over to the actual agenda and take you through what we are going to present for you today. So first of all, we're going to start with the Prover Station platform and the roadmap, and the solutions we offer at Prover in more general to set the scene around Prover so you understand how Prover Station fits together with the overall Prover story. And we're going to look at how you are creating and managing digital twin aggregates for testing and training. We're also going to look at working effectively real proof projects with formal verification. And then there's going to be some discussions around data preparation and validation, and then we're going to have the Q&A in the end. And the Q&A really works pretty straightforward here in Webinar Geek. So you just find the chat and you can type in your questions whenever you want. And the rest of the audience will not see your questions. And when we come to the end of the webinar, we're going to go through your questions one by one. And if we don't have time to answer them all, we will be able to get back to you after the webinar. So with that, I think it's time for me to introduce today's speakers. So here we have today's speakers on stage, Jesper Karlström and Benjamin Blanc. So maybe if you start to say some words about yourselves to introduce yourselves for the audience. Jesper?
Sure, I'm the Chief Product Officer at Prover, and now I'm very much focused on exactly this Prover Station development and figuring out in which direction we are going with it and what to do next and so on. It's a very exciting work for the moment.
Yeah, and then we have Benjamin.
So welcome, Lars. So I'm Benjamin Blanc, so the Solutions Manager here at Prover. Which will benefit from Prover Station, and we are looking forward to being able to work with this incredible product.
So with that, I think it's time for Jesper to start the actual presentation because we have a lot of things to cover today.
Right. So what we want to achieve with this Prover Station is to have a completely new way of working with digital models. We have been working with digital models for a very long time, but we wanted to make them easier to work with. And we think we're on the right path with that. So given several models, you can connect them and build digital twin aggregates now. And that is a much stronger way of using digital models to use them together. We also offer ways to inspect them, simulate, and verifying them. And also, we wanted to improve the way we visualize models because visualization is a way to help new users to get started with formal methods, but also a way for experienced engineers to explain their findings. They might not think that they need so much visualization for themselves, but it's very important to have it when you try to explain to someone else what you found and what problems you want to solve and so on. So Prover Station is what we think is an innovative web-based platform where you can manage digital twins and do formal verification. We work with open APIs to make it easy to integrate Prover Station into your existing environments. So it should be possible to use this tool with whatever you already have. In this first version, we have a few capabilities ready to use. You can configure digital twins and connect them in aggregates, simulate them, monitor them, and view scenarios in track plans. You can perform formal verification activities organized in a new way as proof projects, which I will explain later. And you can also view counterexamples directly in track plans. That makes it easier to understand what's going on when you do formal verification and find bugs using formal verification. In short, what we wanted to do is to add what you need around models, because Prover has focused for a very long time on creating models and investigating digital models, but usually just having the model itself is not enough. So you need to build things around it. And we did that over and over again in our projects, and finally understood that we need to have a ready-made framework to make this easier. I think Benjamin will come back to that later on when he explains a few solutions projects that we have had using digital models and everything that had to be done within these projects. If you truly want to work with digital twins in a workflow where you get the most out of it, you need to be able to easily connect them, because you want to build digital twin aggregates, connecting smaller digital twins into something bigger. So it can, for example, be in a station. You might have a vital computer, a non-vital computer. You might have object controllers and so on. And when you build a digital twin for this station, you build one for each subsystem, and then you want to be able to connect those digital twins to emulate the whole station. Later on, you might want to connect all stations into a full metro line, for example, and then you get an aggregate that is even bigger with a complete line. So we want to make that easier, and I will show you a little bit later on how it's done for the moment. Also, to work with formal verification, we have sold powerful model checkers for a very long time to do formal verification, but we left to all customers to do everything around. So, for example, to organize your proof projects, to keep track of the verification activities you do and what you have done, to remember all the results from individual runs earlier, and to make sure that you cover everything. All this is now handled by Prover Station, so you just have this out of the box. So instead of just having a model checker, you have a web-based framework when you can keep track of the progress of your formal verification activities. We will show this, but first I need to give you a little bit of background on what Prover is, for those of you who have not seen us before. So an overview of the company would be that it's founded in 1996. Actually, as a kind of so not a predecessor, but a successor, it's called, of a previous company that also worked with model checking. We are now a world leader in formal methods and verification of safety critical systems, combining expertise with software development, signaling, and formal methods. So we have one department that do tools development and one department that do services. And Benjamin, who is with us today, is leading the solutions department that are doing services, and will tell a little bit more of what they have been working with regarding digital models. So now, over 20 years, we have applied our knowledge and our tools in the whole world, basically. So to summarize, we know at least over 400 rail control systems that have been developed and verified by the Prover team or Prover tools. And if we also count those that have been developed and verified by our partners, it would be over 1,000. We have customers today in more than 25 countries, and we have presence in 4 countries for the moment. But our headquarters is in Stockholm, Sweden. A little bit more about the history. We started with formal verification in the 90s, originally targeting rail, actually. But pretty soon we tried to cover everything that would need formal verification. So at some point we had nuclear power, we had semiconductor industry, we had some automotive assignments and so on, many different customers. But we specialized in rail and metro applications around 2000, and then extended the offering from not only formal verification tools to also code generation in 2010, and started working with digital twins in 2020. So this also gave us some experience on working with digital twins, and we understood more what we had to build on top of our digital models to actually find a good way of working with them. So we are trying to utilize the experience to build this new powerful web-based platform, ProvoStation, with the following 4 main targets. So we want to give new users an easy-to-use platform for simulation and formal verification. We want to add some visualization support on several layers to aid communication between experts. Also very important for us to stick to open formats and to have partnerships so that it's easy to use whatever we offer in existing environments. And for the same reason, to have APIs for everything. So it should be possible to integrate with whatever you have by transferring data in your database into ProvoStation and so on, but also to automate tasks. So for example, if you have a full metro line, you might not want to click in a GUI to start and stop simulators on the line. You might want to do that via the API to make sure that you can script all those things that you want to happen. So this is the main goals. And I will come back to explaining what we offer regarding digital twins and formal verification. But I will first hand over to Benjamin because he will tell us a little bit more about what the solutions department is working on and has been working on for a while.
Yes, thanks, Jesper. And as is claimed in this introduction slide, the idea is to show 3 small, very simplified example of projects where we think in this team we would have benefited from the ProvoStation and including also our customers. So what we do at Solutions is providing some expertise in different areas. Of course, what Prover is famous for is our incredible expertise into interlocking systems. They could be relay-based, different types of proprietary platforms, and different types of signaling principles that are used throughout the world. And on top of that, we are also providing expertise into more complex signaling systems, including CBTC, ETCS for various customers. Formal methods is, of course, our ADN or DNA since the very beginning. And in that sense, of course, we are providing modeling, formal modeling and verification, including Prover PSL or cutting edge model checker. But also we are very good at providing some support to integrate these capabilities to your ID, to the development environment for a different system, different customers. We do also some requirement engineering, especially, for instance, for some customers to help them coming up with a model before they issue a tender. That could prove very useful in order to have a clear view and a clear explanation of the expected systems in advance, but also for approval. It helps a lot for the customers in that sense. And in such this kind of project, we also give support for principal testing. And when it comes to safety, we provide different types of contributions to the safety case, including risk assessment and various types of standard safety analyses, such as FMEA and so on. And in Solutions, in this department, we are working with our products. So we are working in the idea to help our customers to automate their processes as much as possible using the signaling design automation principles and digital twins. And we are also helping our customers to benefit from open signaling solutions, including code systems. So in the three projects I will present, I will use this different kind of digital twins that we've been using, ranging from white to black. In that scale, white means that we are working at the code level, so that's the final end code that can be in different kind of proprietary languages or general purpose languages such as C or Ada, um, into the modeling. At the other range of the scale, a black box system will be a system that could be left entirely free, free of no constraints. In that sense, the inputs that are fed to the other models are called free inputs. But it can also be defined partially by its racks, so its safety related acceptance conditions, and or also maybe some functional expectations. And in between of these two very different level of modeling, we sometimes use gray box, what we call gray box modeling. And in that sense, it can be used not based on the final code, but on intermediate specifications. And that's proved very useful, for instance, when the system is currently being developed, being implemented, to get some feedback at early stages of the development. So the first example I will describe briefly is the one that is currently ongoing for Stockholm Metro. And the initial idea of this project was to replace part of the interlockings, namely the non-vital part that was implemented using relays into industrial COTS platforms. And for that project, of course, one important need was to ensure that the migration uh, um, confirms or maintains the same set of functionalities that were previously implemented. So the project we had consisted into coming up with a model of the existing systems, including the relays, and transferring this model into a model of the PLC to check and to pass the integration test in order to ensure that the behavior of the expected PLC will be the same than the previous relays. So you can see, for instance, here the TMS is in black because it is present in the final solution that we presented, but is not described at very low level of details, but is left a bit unspecified. Another example that of a project that is currently ongoing. Actually, it's a huge project that we've started in 2019 with Paris Metro, RATP. So it's a joint methodology that we are having with them in order to support their assessment of the CBTC systems that they are receiving. So this consists into defining, to providing with formal verification of some highly critical functions, such as the tracking function of the zone controller of CBTCs, also the mal computation, and other functions such as the odometry for the onboard part of the CBTC. So this methodology goes into two major steps, let's say. The first one being the identification of the apportionment of the risks, the hazards that were the standard collision and derailment hazards that you want to prevent in your railway control system. And the methodology consists into how to apportion it, to derive these hazards into the function at stake. And once this is done, then we come up with a very complex formal model of the function of interest into the open language HLL and the SHLL. And then we apply the prover PSL model checker to investigate and to ensure that these properties are ensured are verified. So in the diagram below, you can see that lots of subsystems are interconnected with different types of communications, And for instance, you can see on the right that this example consists of the tracking function, which is in white because it is based on the final code that is currently commissioned in the system. But that function is embedded into the ZC itself that is just gray because other functions are not described at code level. There's no need for that. So they are left gray in order to keep only the relevant part of this function. And the last example is the one that was triggered by a major change in the New York City Transit during the introduction of CBTC, where one supplier proposed to change the way the system was previously organized around the interlockings by implementing the functionalities that were apportioned to the interlockings into the zone controller directly. So of course, one of the major questions that was raised is whether the functionalities are preserved, and that especially if all the mitigation rules that were present in these interlockings are still verified by the ZC. So here we are supporting the ISA with the prover PSL in order to ensure that the model of the zone controller actually still verifies this safety condition that were previously implemented by the interlocking. So this is why the interlocking here is black, because there are no more interlocking in this project. And the ZC is gray, because here we are starting our work with the low-level specification of the project. So, of course, having a platform such as Prover Station would have been very beneficial for each of these three different projects. And we are really looking forward to get this tool in our project. So I will give hand back to Jesper for the continuation of this webinar.
Thank you, Benjamin. Yes, as you saw, we picked those examples because they are all examples of where we have had many small subsystems modeled, but where the real question is about the interconnection of those subsystems. Questions arise if the connections work as intended, and also if the whole system provides the functionality that it's supposed to provide using those subsystems. So the real question is about the whole digital twin aggregate. Let me bring up this one. So what we offer now with Prover Station is a way to set up, connect, and manage your digital twins in your web browser. So before we delivered individual models, and some customer wanted us to also make those up and running. So we had the special Docker containers for all the models and interconnect them and so on, adding some manual work to just create the digital. The idea is that this will be possible to do boxes on the screen and connect to them. We can create and remove instances, configure instances, and configure links between instances. Then in simulation, we can start and stop instances, and also what goes on in the tracks. So for example, a whole metro line can be up and running in there, and you can connect to one of them and look at the tracks for that, how it behaves, if switches are moving, if signals are lit or dark, and so on. Also, we have those APIs that you can connect to, and that allows you to connect some external simulators, such as our own previous one can be connected to Prover Station like this. But also, if you have your own system, you can connect it. And this also because you could have a piece of hardware connected to all the systems and check that this hardware works well together with an intended environment. We offer for now OPC UA, that is a communication protocol used by many PLCs out there. We also have our own MQTT, what is called, the protocol that is used for simulation. We're also working on the Rasta, which is the links. So that will soon also be implemented. I mentioned about some simulations of digital twins, but it's also good to be able to use verification to prove properties about digital twins. And we took particular care it's possible to use both simulation and digital twins. The simulation is perhaps extra appreciated by it's very easy to understand, and it's also a more traditional method. And what is nice with it, I think, is that it can be used throughout the whole life cycle with different aims. So efficient, just to understand what you want. So you simulate all existing subsystems, and you simulate the prototype, this prototype to the other ones, and investigate them to give you some experience on how it is to use this new subsystem, even though it does not even exist. But you can then write requirements based on your insights. So maybe discover that some ideas you had for these systems, so you replace them and write new requirements. And this allows you to increase quality requirements that actually request what will be good for you in the end. Then during development, the engineers can run simulators again to understand progress of the development. You can try solutions and adjust frequently to produce a better product, and do some debugging very early so you don't find it in VMV, but already during development. Finally, during VMV, so verification and validation, it's pretty common to do simulation to just check what you got, what's the result of this development effort. It's very common to use simulation-based evaluation of a development project. It's sometimes called digital acceptance tests. So it's like a factory acceptance test, but with the hardware in the loop. You just do it with digital models. As a kind of first test to make sure that it behaves as expected. Verifiers can therefore improve their understanding out in various scenarios. And they're safety reviewers, so they are not supposed to do any testing. But sometimes when you make a review, you find something that it's very nice to be able to reproduce a case that you think is suspicious, the system to understand why it works, and then you have learned something and confirm that you don't have to worry about one particular detail. Then after the system, you can reuse simulators again as training. Maybe you want to train your dispatchers, or maybe you want to train support or even drivers, and they can use the simulators to learn more how the system works. Something that we are pretty proud of regarding simulation is support many platforms. And this early as this, because we brought over the simulators from equation-based designs and HLL, and based designs, they can be relay-based. For example, then we encode the relays as equations, but they can also be that work with equations. So it can be structured text, for example, described in an international standard. Ladder logic described in the same standard. This stands for PLCs. So there are a few different languages available for PLCs, and they are described in this standard. Relay-based, I already touched upon. But we also support them. Hitachi, the USNS platform, but acquired, and Alstom VPI VTL is another platform that is on par with Mercloc 2. I would say they are used in similar applications. And then we have the platforms Electrologics and VHLC. They were previously from GE, General Electric, later by Alstom, and now sold to Knos. Rather popular platforms in the US and in the UK. And finally, Siemens can also be seen as an equation-based platform. It's actually a kind of, but it works to model it as a based platform. And again, then, to have the possibility to connect external simulators or even a traffic management system or a hardware in the loop, we offer OPC UA or MQTT as options to connect, and soon also the raster protocol. What is nice then with our digital only do simulation, you can inspect the program, so happening live, but you can also run formal verification for various aspects to check that requirements you have. And this brings me to the next capability that we have projects. So the idea is to offer a way to organize your formal verification work in projects. The goal is to have, so first we have a model checker called Prover PSL that has been very appreciated by the market, but many customers asked for a graphical user interface of this because it was command line based, and this was liked by many, but also considered to be a threshold to start using model checker. So we wanted to create a graphical user interface, and then the idea came up to not develop something special for Prover PSL, but to make this a part of Prover Station that we're also working on at the moment. So you can view this as a kind of front end to Prover PSL, but not only able to run Prover PSL, it also offers some proof management. Everything that you can do in Prover PSL, you can also do from Prover Station. So that means you can load HLL or SHLL models, simple strategies or advances. You can produce proof logs. You can produce counterexamples. But now we also added those in values or values of variables, graphical representation samples, which that helps a lot for understanding what's going on. Another thing that we knew that our users had to do was all the proofs, because the tool Prover PSL, those were not. And then you had to continue working with the ones that you could improve and maybe change strategy and so on. And it was pretty easy to get lost. Framework to administer proofs for project, to understand the progress of your proof project, and also when a new result is available. So if it's a very long run, you can and then you can leave for the day, and when you get back in the morning, you will have a result to look at. What we offer here in the proof project is a kind of overview, and then it also runs. So you know from a proof obligation that if it has runs, then it's actually valid. And this proof station, you can also do proof under assumptions. So for example, if you but you assume that it will easily follow, and then you can try this idea by asking for proof under assumption, proof obligations, and prove some others. And if the model checker confirms that the other ones would follow, if the first ones were proved, then you can focus on proving the first ones. And this is complexity, because then you get dependency between proof. This was also known to be one of the applications we introduced, and an assumption graph where you can see which assumptions you have and what remains to be proven and so on. We offer a very good default proof strategy to configure the proof strategy to succeed with your proofs. But if this is not sufficient as before, what is new then is that we offer a graphical interface for editing the proof strategy. So it's much easier, both because you get a nice orders exist and what you can do with them. So a little bit you have been working with or even struggling with strategies before. Try this and see if it helps you. I mentioned to be able to look see what goes on in the tracks, and for that we added plans in Proof Station. The idea is to improve the efficiency of the whole team, illustrations like this of tracks. So for example, if you have a counterexample from formal verification, and you can view the various steps and view what happens in this counterexample in the tracks, see where the train is and how the switches move and so on, and understand where it can happen. Or if you simulate, you guess what goes on, and that can be used for simulation, but also for the kind of stepwise simulation that you can use, where you step back and forth in time by clicking one step ahead or backwards. Compatible with ProRiloc. So if you have a layout in ProRiloc, I want to say a few things about data preparation also. It's so with data preparation we mean that you select parameters for various systems, and then with data validation, that means that you want to check that those parameters are actually good ones. And for this, we see a big need, but we are not there yet. So we are working on this. It's an upcoming feature to prepare and validate critical data parameters. So for data preparation, you write rules to generate template data. You can do manual adjustments to the data and read back to modify the model, and then visualize the result of the data. And then for data validation, you can check that those parameters that you have set fulfill some safety requirements. For example, if there is a requirement that for every switch there needs to be some flank protection, for example, and you have some RBC that requires you to add flank protections for each switch, then you can check that your parameters is set in a good way that will provide flank protection for every switch. Okay, now we have had a quick overview of what we have been doing so far and where we want to go with this. And the next step would be to try what we have. So if you like, you could try Proof Station for digital twin aggregates. You would use Proof Station to set up and monitor digital twin aggregates. And to do this, you would have to license a few components. So Proof Station, obviously, but also then Proof Studio is a tool for writing and checking specifications, formal specifications. It supports HLL, SHLL, or PySpec, which you will use together with this. You will have ProRiloc layout editor for drawing track plans, and then you can pick an execution model. So for example, if you want to work with a Merkloc project, you would use a Merkloc execution model. Or if you want to use to try some electrologics thing, then you can use the electrologics execution model. And also, if you don't want to run everything in ProStation, you can also use the and debug the simulation model before uploading it locally on your side. We offer right now a limited number of free evaluation licenses. So if you contact us, if you're interested, we can discuss, and we will select a few that for free. What we want back is that you help us evaluate and tell what you think about things and what you would like to see more of, found useless or even confusing, because this is a mature product, so it's precisely as we think will be good, but you always need feedback from users to have a good product. That's what's in it for us. We get back from you some opinions, which also gives you, of course, an opportunity to influence our roadmap. Offer this now as a cloud-based solution, if you prefer, or an on-premises installation. If you have an on-premises installation, that would mean that your IT department or someone at your company would install this in your own servers. The advantage of that would be that you keep the data on your side, so you don't have to worry about cybersecurity and so on. But it will require some manual updates when we have new versions. It will not be automatic as it is if you go cloud-based. But this is something we can discuss. In these evaluation projects, we also offer trainings that will be included because we want to ensure that you learn how to use this in an efficient way, and also that would be an opportunity for us to have feedback on what's good and what we need to improve. The other possible evaluation project that we would like to do with you, if you're interested, is ProverStation for formal verification. So you would use ProverStation together with Prover PSL to do formal verification organized as proof projects. You would have to license some other company ProverStation again, but then Prover Studio for writing and checking HLL specifications. Prover iLock layout editor for drawing layouts. That's Prover PSL, the model checker used as a then in ProverStation. We have a few add-ons that could also be selected if needed in the evaluation. So it would be floating point numbers or SHLL support or stability analysis add-on if you want to analysis. It's the same. We have a few limited number of evaluation projects that we plan. So if you're trying this out, contact us and we discuss something. The delivery method here you can choose between cloud-based or on-premises. And again, there is another option also. Maybe you would like to see more before we decide on this. And then you're very welcome to book a demo, because we have a meeting where we discuss with you how you want to use this and how you could get the most out of it. Set up a demo session where we show you work to achieve your goals. The easiest way for you to ask to participate or to do an evaluation project is simply to reply to an email, because tomorrow you can email and you just reply to that email to book that city. Okay, we are at the end, so that means that we will have questions and answers.
Yes, we will. So we'll bring back Benjamin as well. And just as Jesper said, tomorrow you're going to receive this email. So you have the contact details, and the easiest thing to do is just as Jesper said, to reply on that email. So we can help you out based on these offers that Jesper's been presenting. But in that email, you will also find a link to the recorded version of this webinar, so you can look at it again or share it potentially with others in your organization. So Q&A, well, it's a chat functionality in Webinar Geek, and you can just type in whatever questions you have, and we will do our best to answer. So we'll just have to see now if there is any questions here. We'll see. There's not so many questions coming in.
Everything was crystal clear.
Everything seems to be crystal clear. So let's see. Well, seems to be
But then
pretty
we can say
crystal
that
clear.
if you want, you can also write questions by replying to the email tomorrow. If you
Yeah,
cannot.
of course you can. Of course you can. So doesn't seems to be much questions coming in here. So and so guys, I think we everything was pretty obvious and pretty clear, and we hope that people really enjoyed this Proof Station product launched, and we will sort of close down the webinar for today. So I would like to say thanks to everyone, and it was really a lot of you that took your time to join us today at this webinar and this product launch. So thanks a lot for that. And then, of course, thanks to Jesper and Benjamin sharing their knowledge and experiences and all the know-how around Proof Station. So it's going to be an exciting journey for Proof Station going forward. So thanks, and we'll close down the webinar. Maybe some final words from the speakers. Well, I can see now that there is some questions coming in, by the way.
Or comments, maybe.
It's more comments, yeah.
But it's good to see that you found it useful.
Yeah, they seem to like it. So any specific final comments before we end? Jesper, Benjamin?
Benjamin,
please,
go ahead.
Okay, yeah, just want to thank everyone, and that was really interesting for us also to coming up with this webinar, gathering everything that led to this journey. So hope to see you on board with us.
Yes, and we actually had a question here.
Yeah, there is a question coming in. I want to know more about LCF. Yeah, so let's elaborate on that before we close down then.
Yes, I'm sorry about that because I didn't even mention LCF today. LCF is a layout configuration format. It's an open format where the specification has been published, and the idea is to have a format where you can define a track plan, but you can also define other configuration data. The advantage compared to, for example, RailML, which is more famous, is that RailML is an XML-based format, which requires you to have tools to interpret. With LCF, it's text-based, very similar to JSON, so it's very easy to read the format itself, which makes it excellent for safety review without having to develop expensive review tools. We base, actually, it's nice that you ask because we base this track plans, the tracks that you saw, we base that on LCF. So we use it ourselves, and Proof Station is compatible with it. But we wanted to be a bit economic with time today and not talk about LCF. But let's keep in touch if you are interested, and we can hear what you want to know about LCF.
Okay, with that, I think we'll close down.
No, we have
there's another question. The questions are coming in. Yeah, so we'll look into this one. Is your R&D team looking forward to extend your technology in another transportation domain, such as aviation traffic control, for instance? That's an interesting question.
That's very interesting. I mean, we always look for new verticals, as it's called, to find new areas where our technology can be applied. We are not actively looking, but whenever there are opportunities, we always explore them. Most of our technology is actually not domain-oriented. For example, the proof projects could be done exactly as is, even in other domains. The track plans, of course, are rail-specific, but those are the only ones that are actually rail-specific. We know there are applications of formal verification in other domains, and we follow that closely. We have contributed, as I mentioned in the beginning, a long time ago. But we also decided about year 2000 to focus on rail and metro, and that is because to actually follow all domains at the same time and have salespeople that are experts on both rail and metro and aviation and semiconductors and so on, it's impossible to make a good job if you try to target everything. So what we do now is we focus on rail and metro. Then we have some partners. So we have, for example, Simulink. You might know that is used quite a lot in aviation, and that they have a design verifier built into. So Simulink design verifier, that's actually powered by our prover P-cell inside. And also the SCADE tool, the French one, is also used both in aviation but also in automotive and so on. Simulink even more in automotive, I think. And there is also SCADE design verifier powered by our model checker prover P-cell. So we are handling that with agreements with Simulink and SCADE. But if someone would contact us and wanting to do a project with aviation or automotive, we would of course be interested.
Yeah, now there's a lot of questions coming in, so we'll continue this webinar. So we have another one. Do you have integrations with IBM Doors and requirement management?
Maybe I can have this one.
Yeah, go ahead.
So we don't have direct integration with that, but there is an export format from Doors that we are currently using, which is the RKF triplet, and we have integration with that. So that allows us to connect to Doors, for instance, but also to Polarion and other systems. So it's some sort of underlying standard that are used in these different platforms. But of course, there is a need for us to be connected to this requirement management platform so that we can ensure the traceability of our products and our artifacts that we are developing during verification projects to the requirements.
Okay, so thanks for that. Then another question: are you investigating to implement an interface with Rail ML?
Yes, of course, and this is an example of an open format that we will support. So that's also ongoing. It's a little bit tricky because the LCF format has a different. We need to converse between Rail ML and LCF, and they are pretty different in how they organize their data. But it will work. There's no question about that. So it's ongoing. It will soon be there.
Okay, so interesting. And then we have another interesting question here. The movement in railway domain is quite linear in contrary to aviation, which were non-linear. How good is your prover product in non-linear functions?
So I would say it's not so relevant that planes move in a 3D direction, because what you would prove is not anything about the path of a plane. It's more that you prove properties about subsystems and then properties about systems of subsystems. So it's in both cases there are software programs, and they are not that different in how they work. So we have done work for aviation and it worked perfectly fine. So there is no difference in practice. And if it's linear or non-linear, it's rather the case that if a software system is created to fulfill safety requirements, then it will be. They are not chaotically created. They are created with a goal to actually fulfill safety requirements, and that is what makes it possible to prove that they are actually fulfilled also.
Okay, thanks Jesper for elaborating on that one. I think we have another question here as well regarding LCF. Can LCF be used for static data preparation rules?
Yes, and that's the advantage. So LCF itself can explain, it's a way to explain the topology or to define the topology and the connections between elements and so on. And then there is a way to express how you can derive data from this. So for example, train routes, maybe they are derived because they start at a signal and they end at the next signal. And you can express rules like this and then automatically derive the train routes that you will have in a track plan. And this, the whole machinery around this is also currently under assessment for SIL 4. So it would be the highest software integrity level that is defined in the Senelec standard. So if you are in rail, you probably know that we are governed by a Senelec standard, is some European norms that you need to follow. And if you use tools to prove correctness, you need to stick to many principles on how you develop that and how you also verify and validate that. And it's possible if you're doing a good job and document what you're doing, then you can receive a certificate from an independent safety assessor saying that this tool fulfills the requirements for Senelec SIL 4. And we are working now on making this LCF machinery approved by an external independent safety assessor.
Okay, we have another question as well here. Let me see now. A decade ago, the prover had been used as the background SMT solver in the MathWorks products. Is it still the case? Is the cooperation between prover and MathWorks still ongoing?
Yeah, yes, it is. This is what I mentioned with the Simulink, because Simulink is the name of the tool that MathWorks provide. They also do MATLAB, but this is Simulink, and in the Simulink Design Verifier, that is our technology. So the decade ago, it was already there, but it was an old version, and then now they have a deal that they have every time we make a new release, they have the updated version. And they make themselves 2 releases per year. So every 6 months, they update the version of the Simulink Design Verifier based on what we send them.
Okay. So I think we've been able to answer all the questions so far. It's only 3 minutes left. So I just would like to say and repeat what Jesper said earlier. You're going to get the email tomorrow with the contact details and also a link to the recorded version. And you can reply on that email to be able to get access to the offerings that we've been talking about here during the webinar earlier. So with that, I would like to say thanks and bye-bye. And we're going to close down the webinar. So let's close it down. What do you say, guys?
Yes. Thank you for today. See you.
Thanks, Lars. Thanks, everyone.
Thank you. Bye-bye.